Hey, welcome to episode 2 of turning wrecks into checks. We got our Jacobsen mower, Jacobsen batwing mower in the shop. We're going to try to do a little troubleshooting today and try to figure out why it's cutting off when you push the pedal down. So every time you push the pedal down to go into reverse, the engine just cuts right off, and we're going to do some troubleshooting to try to figure out what's causing that to happen. I was thinking about it, and the way this thing works is it's got a pedal, and it's actually got a mechanical linkage going to the hydrostatic transmission. So I was looking at it, and it's only 2 ways that this machine knows it's going in reverse. It's got a neutral switch. I can show you it. This right here is the bottom of the foot pedal linkage. This orange piece right here connected to this wire is a neutral switch, and basically when you push this pedal to go into reverse, it moves forward. When you push it to go into forward, it pivots and this goes backwards, but it only knows it's in neutral when this bolt right here hits the magnet in the center of this pedal. If this bolt, which is metal, if it moves back or forth, comes out of that magnetic realm, then this sensor knows that it's going forward and it's going backwards. So it also has another switch, which is right here, and it's just a ball that rides on this block. So when you go into reverse, that switch pushes on that ball, and then it pushes the switch when it hits this block. So other than that, it's just a mechanical linkage that's just going back to the transmission. So it's only 2 ways this thing knows that it's in reverse, and it's got to be something with one of those. I'm not sure if one of those switches is bad or what the information that it's telling is getting mixed up somewhere. So figured that's a good place to start. We'll troubleshoot that. Hopefully we can hook this multimeter to it, and then we can push this pedal one way or another. We can see if the readings are fluctuating or not. Alright, so I've got the multimeter hooked up. It's a 2-wire switch here. This is the reverse sensing switch. It's just a 2-wire switch. I've got the leads plugged right into it. So when I push this pedal to go into reverse, hopefully it'll change from open to having some resistance. So yep, when I go to reverse, it changes to resistance. Go back to neutral, open. Resistance, open. So that's working exactly like it should, but as long as it's reading, we know it's working. So that checks off the list. Alright, so we tested the neutral switch, the parking brake switch, the reverse sensing switch, also tested the seat switch. So now I brought up this schematic here, and I'm trying to figure out what's next in line past the seat switch. So if you look at it, I just started all the way to battery. The power comes from the battery, starter motor, 50 amp circuit breaker, 30 amp circuit breaker, splits off and comes around through a 10 amp circuit breaker, and actually goes through the PTO switch, and then it comes down to the seat switch, and then once the seat switch is closed, then comes to a time delay relay, and you have to have a low amount of power to pull this bridge down and then connect this higher amount of power here. So that's next in line. We'll test this time delay relay and make sure that's working right. Alright, so we got the control panel taken off, and I located the time delay relay. It actually looks nothing like a normal relay. It's just a black box with 2 screws on it. It's just bolted right to the side of this control panel. It's a 3-wire time delay relay. It's right there. And I found on a part of that schematic where it says how to test it. Connect one test lead to terminal 1, connect the other test lead to terminal 2, and if continuity is indicated, if it is, the relay is faulty. If no, then go on to the next step. So getting ready to hook this up to terminal 1 and 2. Hopefully we do not have continuity. Alright, it looks like we don't. It's showing open. So far it's testing good. We're going to this next step. Next step is connect 12 volts to terminal 2 and 3, and then connect the ground to terminal 4. Measure the voltage between terminals 1 and 4. If approximately 12 volts is indicated, the relay is good. If you don't have 12 volts, the relay is faulty. Replace the relay. So that's what we're going to try to do now. Typically, key switch has got unswitched power coming to it. So I'm going to test which, put this on voltage. I'm going to test which terminal on this key switch has got 12 volts. Oh wait, let me see. Okay, it's actually, that one's not showing any. This bottom connection down here is showing 12.6 volts. So we do have unswitched power coming to that terminal of the key switch. I'm just going to run a jumper wire from that terminal of the key switch and then power this, run power to this time delay relay, and then we can do our test. Alright, so what I'm doing is I ran power from the unswitched power going to the key switch. I got a jumper wire coming around going to this middle terminal here, and then it says you got to power this terminal and this terminal. So I'm just going to run another jumper from this main power wire over to there, so both of those terminals. Oh, you hear that? It clicked. So now I'm going to test between this terminal and ground and see what we got going on. So, bless you. Bless you. Let me test the ground. Alright, so it shouldn't say we have 12 volts. Let's see. And we are not getting 12 volts. Let me make sure this is connected right. Yeah, I got that on ground. Testing that. Got this hooked up with a jumper. We are not getting 12 volts. Well, that could definitely be our problem then. Yeah, we are supposed to be getting 12 volts right here, and we're not getting it. So, could definitely be a faulty time delay relay. It's not testing 12 volts. The first time we tested it, it was supposed to be testing open, and it was. So we went to this next test, and we're not getting 12 volts. So I say we order a new time delay relay, put it on there, and see what happens. Alright, so I had a new idea. Instead of waiting for a new time delay relay to come in, I'm going to just try to bypass the one that's on here and just verify that the problem works. So basically what I've done is this is the connector that comes up to connect it to the time delay relay, and I'm just going to bypass this whole circuit, and I'm just going to put a jumper in here from this wire to this wire and trick it and make it think that it is getting voltage all the way through. And if that fixes the problem, we definitely know that the time delay relay is what's causing it. So yeah, we'll test it and see what happens. See if I can back up. What? Oh my gosh! It worked! It worked! It's fixed! Oh yeah, must be fixed. So,
must be a time delay.
that's definitely a problem. It was definitely definitely a time delay relay. We bypassed the circuit. It's working fine. The blades are cutting on. It's driving in reverse. So we'll get a new time delay relay on order and stick it on, and this machine will be good to go.